Right, in this video we're going to go through the solutions to the May 2025 IB AASL paper. It's paper 1, time zone 1, and we'll start with question 1, which is a straightforward log laws question. So if you don't know your log laws, look them up in your formula booklet, and I've written them down here. And we're just going to apply them to each of these questions. So in the first one we got ln 3 plus ln 4. So if you look at your first of the log laws, we can see that the logarithm of something plus logarithm of something else is just the logarithm of these two things multiplied together. And that's going to be the same as ln 12. Okay, and then for B, we've got 3 ln 2, and if you look at the third one of your log laws, you can see that the thing that goes in a power, x to the power of m, is the same as multiplying by that in front. And here we have something multiplied in front, so that means that we can put that into the power, so it's the same as ln 8. Okay, and finally the third one, C, is negative ln of a half, and the log law with divided by, you can see that the log of 1 over 2 is going to be the same as ln 1 minus ln 2, and ln of 1 is just equal to 0 because e to the power of 0 is equal to 1, so we just get negative ln 2, which is ln 2, and that's it. Okay, so let's look at question 2. Consider the function f of x is equal to 4x cubed over 3 minus 16x, and the graph has a local minimum point at the coordinates pq, where p is positive, and we have to find the value of p and q. So we can do a very rough sketch of our cubic. It's going to be, it's as a positive coefficient of x cubed, so it's going to be a positive like this, and it goes for the origin, because when x is 0, f of x is 0, so it looks a bit like this, and the point that we're interested in is pq, which is local minimum. So we know the first one has to be a maximum and the second one's a minimum. And the way to find the coordinates is to first differentiate. So multiply by 3 and put the power down by 1 and 16, and we know that this whole expression has to be equal to 0. So 4x squared minus 16 is 0, 4x squared is 16, so x squared is 4, and that means that x is plus minus 2. But we already know that x has to be positive because p is positive, so the value that we're interested in is p equals 2. And then we have to find q, and q is the value that the function has at this point when p equals 2, when x equals 2. So we go back to the original function f of 2, and we get 4/3 times 2 cubed minus 16 times 2. So 2 cubed is 8, 4 times 8 is 32, minus 32. So we could factorize this to make it easier to see that this is actually a negative 2/3 of 32. And that's minus 64 over 3. So that means that q is negative 64 over 3. And p was equal to 2. Question 3. Bob invests 1,000 dinar in an account which pays a nominal annual interest rate of 4%, compounded quarterly. And the amount of money in the account after one complete year can be written as this, where k is a real number. We have to write down the value of k. So I copied this formula from the formula booklet, where the terms are explained here. So FV is the future value, PV is the present value, N is the number of years, K is the compounding periods per year, and R% is the nominal annual interest rate. So basically what we're going to do for part A is to write down this formula with the numbers that we know and find out what K is. So the future value is still just FV. The present value is 1000. And in the brackets we have R, which is the percent nominal annual interest rate, which we were given as 4%. And we're dividing it by 100 times this K, which is the compounding periods per year, which is 4. And all of this to the power of Kn. So it's to the power of K, and then N is how many years, and we're talking about 1 year. So it's just 4 times 1. So it's all of this to the power of 4. And it's already looking very similar to the formula we want. All we have to do is to say it's 4 divided by 400, which is 0.01 to the power of 4. So therefore K is equal to 0.01. Okay, and part B, expand and simplify 1 plus x all to the power of 4. And to do this we're going to need Pascal's triangle, is the easiest because it's not very large power. So we write down the first few lines of Pascal's triangle. This is enough lines because when it's to the power of 4 we're going to have 5 terms, which we already have here. So it's going to be 1 times 1 to the power of 4, which is 1, plus 4 times 1 to the power of 3, x, and then 6, 1 squared, which is 1, and then x squared, plus 4 again, x cubed, plus x to the power of 4. And that's already simplified. So that's all for part B. And for part C, let's make some space over here. Okay, so hence or otherwise, find the amount of money in the account after 1 complete year, giving your answer correct to the nearest dinar. So that basically means that we're going to put the numbers into this formula. So let's start off by writing this expansion with 0.01 because that's what the K value was in part A. So we want to write the expansion with this, which is the same as 1 plus, and then we have 4x, where x is equal to 0.01. So 0.04 plus 6 x squared. So it's this. And I'm not sure we need any more decimals, but the next one would be another 2 zeros and then a 4, and then there's going to be something really tiny because we're going to multiply this by 1000 to get the final value. And I don't think we're going to need that last time anyway, because we're going to round it to the nearest dinar. And we already have 1000 times 1.0406. So when you multiply this out, you get 1040.6. So rounded to the nearest dinar would be 1041 dinar. Right, question 4. Find the area completely enclosed by the curves y equals e to the power of x and y equals negative e to the power of x. And the lines x is minus 1 and x equals 1. And for this one, even though the question doesn't ask us to show the graph, it's actually going to help us if we do a quick rough sketch of what the graph looks like. So it's an exponential growth and it's going to look something like this. And y equals negative e to the power of x is going to be a reflection in the x-axis of this. So this is what the two curves look like. And we also have two lines, x equals -1 and x equals 1. So the area that we want to find is this area here. And you should be able to see from this that by symmetry, this area is actually going to be, is the same area between y equals e to the power of x and the x-axis as it is from e to the power of -x and the x-axis. Just that this would be a negative area when we integrate it, and this will be a positive one. So what we want to do is to just say that the total area is equal to double the integral of e to the power of x dx from -1 to 1. So that means that we only have to integrate e to the power of x. And integrating e to the power of x, you get e to the power of x. And then we substitute the limits in. So you get e to the power of 1 minus e to the power of -1. Which is the same as 2 times e minus 1 over e. Okay, so let's look at question 5, which is a 6-mark question. It says, consider events A and B such that the complement of A has a probability of 3/4, A or B or both has a probability of 3/4 as well, and probability of B given that A has occurred is 2/3. And we have to find the probability of A and B. And I copied some formulas from the formula booklet. And 4.6, there was combined events, which is this formula, conditional probability, which is this formula, and independent events, which is this. And if we start with part A, what we're going to need is the conditional probability formula, because this one combines the intersection of A and B with the conditional probability. So this is, we can rewrite this as probability of B given A is probability of A and B over probability of A. And the reason why we can switch A and B around here is that the probability of B and A is the same as probability of A and B. It's just this intersection part of the Venn diagram. So we can use this, and it means that we're going to need a probability of A rather than a probability of the complement of A, which is going to be 1 minus probability of the complement of A. So 1 minus 3/4, which is 1/4. And now we can rearrange our formula. So probability of A and B is probability of A times probability of B given A. And we put our numbers in, 1/4 times 2/3, 2/12, which is 1/6. Right, so that's the answer to part A. And now we look at part B. Show that events A and B are independent. And we have our formula for independent events here. The probability of A and B that we just found has to be the same as probability of A times the probability of B for them to be independent. And to test that, we need to find probability of B. That's what we're looking for. And we're not given any probabilities with just B. So we have to go back and look at combined events. So for combined events, let's write it down. The probability of A or B or both is the probability of A plus probability of B minus probability of A and B. And this is a good one for us because we know the probability of A or B or both is 3/4. We know this and we know this, and now we can use all of that to calculate P of B, probability of B. So we're going to rearrange this plus this minus this. And A or B has a probability of 3/4. A and B, we just calculated, was 1/6, and minus 1/4. And 3/4 minus 1/4 is 2/4 plus 1/6, which is also 3/6 plus 1/6, which is 4/6 or 2/3. Okay, so probability of B is 2/3. And now we're going to test whether the condition for independent events is satisfied or not. So we're going to multiply probability of A by the probability of B, which gives us 1/4 times 2/3, which is 2/12 or 1/6. And then we're going to look whether that's the same as probability of A and B, which is what we calculated here, and it's the same. So therefore, they are independent. Right, question 6. And this one looks a bit scary at first sight, so let's just do it step by step. So we have 10 rectangular picture frames, F1 to F10, and F1 has width 4 centimeters and height 5 centimeters, like I've drawn here. And after that, we increase the width by 50% to get the next width, and the height by 50% to get the next height. And I've drawn F2 here, and you could also continue, but I think this is enough for now. Let's do part AI, which means that we're going to show that the area of a picture frame is equal to this expression here. And as you know, the area is the width times the height. So we first want to write expressions for the width and the height. And the width of picture frame N is going to be 4 times 1.5 to the power of N minus 1. And N minus 1 is because we want the factor to just be 1 when N is equal to 1, because the first picture frame gets a width of 4 centimeters, and then the next one you want to multiply by 1.5. And for this question, it's going to be better if we write it as 3/2 to the power of N minus 1. And similarly, for the height, it's going to be 5, not 6. 5 times 1.5 times to the power of N minus 1, 3/2 to the power of N minus 1. So that means that the area of picture frame N is going to be the width of frame N times the height of frame N. So we multiply these two together. 4 times 5 is 20. And then we have 3/2 to the power of N minus 1 times 3/2 to the power of N minus 1 again. And these two we can combine because they're both to the power of N minus 1, and they're both 3/2. So basically they combine to give us 9/4 to the power of N minus 1. Okay, and then let's do part 2. So hence find the mean area of the 10 picture frames given your answer in this form. So the mean area is going to be the total area divided by n. So we can write this as the sum of an divided by n, and it's the sigma always looks a bit scary, so let's actually expand sigma of an is when we're summing over all 10 picture frames using this area expression that we had. So it's going to be, for n equals 1, is going to be equal to 20. And for n equals 2, it's going to be 20 times 9 over 4 to the power of 1, and then plus 20 times 9 over 4 squared, and so on. That's going to continue. And the last term is going to be when n equals 10. We're going to have 20 times 9 over 4 to the power of 9. So these are all the areas that we're summing together. And as you can see, this is actually a geometric series. And we have the first term equal to 20, and the common ratio is equal to 9 over 4. And you can look in your formula booklet, you can find the formula for the sum of the first n terms of a geometric series is this. And now we can use this. So we can see that the sum of the first 10 is going to be 20 times r to the power of, right, the double brackets, r to the power of n minus 1, and then r minus 1. Right, this looks a bit messy, so let's tidy it up a bit. We can, well, for now we can keep the numerator as it is, 9 over 4 to the power of 10 minus 1, divided by 9 over 4 minus 1 is going to be 5 over 4. And that means that we can multiply by 4 over 5 in front instead. So we get this. 9 over 4 to the power of 10 minus 1. And let's look at what we want to end up with. P times 9 over 4 to the power of a minus 1. So it's already looking a bit like this. So let's do the 4/5 of 20 is equal to 16. 9 over 4 to the power of 10 minus 1. Okay, so now we have the sum of the areas, but we needed to divide it by n as well. So let's move up here. The mean area, let's call it mu, is the sum divided by n, and n was 10. So this is going to be equal to 16 over 10 times 9 over 4 to the power of 10 minus 1. And 16 over 10 is the same as 8 over 5. And now we can't simplify it anymore. And we do have q is a rational positive number. Yeah. And a is a positive integer. So we do have it in the right form. So that's the final answer. Right, so part B, we're going to find the median area of the 10 picture frames, giving your answer in this form here. And finding the median of 10 things, if you imagine lining them all up, F2, F3, and so on, if we have 10, that means that there's going to be 2 in the middle because it's an even number. So the median is going to be the mean area of F5 and F6, because they're going to be, the middle is going to be between F5 and F6. So the median is actually going to be A5 plus A6 divided by 2, because when you have two numbers in the middle, you take the mean of those two. So now we plug that into the formula we had for the first part, which you can't see here, like this. Okay, and we're going to plug in n equals 5 and n equals 6. So we have 20 times 9 quarters to the power of 4 plus 20 times 9/4 to the power of 5 all over 2. And the first most obvious thing to do now is to divide through by 2. And we're basically looking for ways of making this look like this form. So we want a rational number times 9/4 to the power of 4. So we want to combine these two terms. And we can do that by factorizing. So we can take 9/4 outside the brackets. And what we're left with, actually let's take 9/4 to the power of 4 outside the brackets, because that is a factor of each of these. So then what we're left with is 1 plus 9/4. And this is already looking better. So we get 10 times 9/4 to the power of 4. And here we have 4/4 plus 9/4, which is going to be 13/4. So we get 10 times 13/4 times 9/4 to the power of 4. And 10 and 4 are both divisible by 2. So it's the same as 5 times 13/2 times this. And 5 times 13 is 65. And now it's already in the right form, because Q is a positive rational number, and then we've got 9/4 to the power of 4. Okay, let's move on to section B. In question 7, we have an object moving in a straight line, and the velocity is given by this function here for the first 5 seconds. And we're given the graph, and we know that the graph has a local maximum when t equals 1. So that's going to be here, and it intersects the t-axis at t equals 3. Okay, and we have to calculate first the maximum velocity. And we've already been given that the local max is when t is equal to 1. So all we have to do is find the velocity as t equals 1. So we write down the function minus 10 times 1 squared. So we get 30 plus 20 minus 10, so 40 meters per second. And then the maximum speed. So if you remember, velocity is speed but taking the direction into account, whereas speed would be the magnitude of the velocity. So we basically want to compare this maximum that we just found. You want to compare the magnitude of that with the speed. Where else is the speed high? It's going to be here. When t is equal to 5, we have a very high speed, because the line is a long distance from the t-axis. So we want to compare it with the velocity at time equals 5. So we calculate v5, and plug it into the same formula. 20 times 5 minus 10 times 5 squared. Let's simplify a bit. 250. So it's plus 130 minus 250. So it's going to be minus 120 meters per second. So the magnitude of this is basically 120, and that's larger than 40. So the maximum speed is equal to 120 meters per second. Okay, so for part B, it says that at t equals capital T, the object changes direction, and we have to write down the value of capital T. And changing direction means that the velocity goes from either from positive velocity to negative, or from negative to positive. And in our case, we start with a positive velocity, and then at this point, it changes to negative. And we know the t value here, because that's when they intersect the t-axis at t equals 3. So it just says write down. So we just write down that t is equal to 3 seconds. And part 2, find the distance traveled by the object in the first t seconds. And distance from velocity is an integral. So distance is the integral of v of t with respect to t with the time limits. So in our case, it's going to be from 0 seconds to 3 seconds. And the function is this one. So 30 plus 20t minus 10t squared. All of that integrated with respect to t. And 30 gives us 30t plus 10t squared minus 10/3 t cubed. And when we substitute these values in, when we get to the 0, it's all going to be 0, so we can ignore that. So let's just substitute the 3 in. So we get 30 times 3 plus 10 times 3 squared minus 10/3 3 cubed. So it's 90 plus 90 minus, right, so the 3 cancels with one of these, so we have 10 times 9, so it's also 90. So we get 90 meters. Okay, so now let's do part C. Determine whether the object returns to its initial position during a time period from 0 to 5 seconds, justifying your answer. So we've just calculated that the distance that we traveled during the positive velocity is 90 meters. And now we want to know if we're traveling back more than that or less than that. So what we're interested in is this part of the curve when the velocity is negative. So what we can do is integrate the function between 3 and 5 seconds. And we've done the integration already, so we can just remember what we wrote on the last page. We had 30t plus 10t squared minus 10 over 3t cubed. And now the limits are 5 and 3 to find out how much we're traveling in this direction. Okay, so putting all the 5s in, we get 30 times 5 plus 10 times 5 squared minus 10 over 3 times 5 cubed. And putting the 3s in, if you remember, we got 90. So it's just minus 90. And let's work this out. 5 squared is 25, so 250. And 5 cubed is 125 times 10 over 3 minus 90. Okay, so we have 400 minus 90 is 310. And then we're stuck with this fraction here. So let's write it for now and deal with that separately. So 1250 divided by 3, 12 divided by 3 is 4, 5 divided by 3 is 1, remainder 2, 20 divided by 3 is 6, and also remainder 2. So it's 416 and 2/3. So the distance back is 310 minus 416 and 2/3, which is equal to negative 106 and 2/3. So we're comparing 106 and 2/3 that we're traveling back compared to 90 that were traveled forwards. And we're basically traveling further. We're traveling further back than we went forwards. So we can say yes. Yes, it returns to its initial position because it travels further back than 90 meters. All right, question 8. The function f is defined by this, and x is a real number. And we're going to write f of x in this form, which is the vertex form. And let's start by expanding the brackets for this part of the function. So we get x squared plus 3x plus 1x, which is plus 4x, and then plus 3. And we can leave the 5 outside the brackets and do complete the square on this part. So if we think about what this would give us when we multiply it out, it would give us x squared plus 4x, and then it would be plus 4. So let's do minus 4, and then plus 3. So that takes us back to what we already had. And we can simplify this already before multiplying it out. We can combine the minus 4 plus 3. It's going to be minus 1. And now we multiply it out. So we get 5 brackets x plus 2 squared minus 5. And that's in this form. So h is negative 2 and k is negative 1. And part B, sketch the graph of y equals f of x, showing the values of any intercepts with the axis and the coordinates of the vertex. So that means that we need to do a few calculations first. So we had our vertex form of the quadratic, and we can use that to find the vertex. So the vertex is at coordinates h, k, which in our case is going to be negative 2, negative 5. And then we need to find the intercepts. So we can do f of 0 to find out the y-intercept, and we can use the completed square form again. So 5 times, when x is 0, we get 2 squared minus 5. So 5 times 4, 20 minus 5 is 15. And we also have to find the other intersection, which is when it intersects the x-axis. So we're going to find out when this equals 0. So let's go back to the original form, which was this. And let's find out when that equals 0. So one case would be when x is equal to minus 1, or when x is equal to minus 3. So these are the two roots of the equation. So now let's try to sketch it. So we're going to have minus 1 is going to be crossing, and minus 3. And we're going to have a vertex down here, and then a y-intercept up there. So let's draw quadratic. And the vertex is at minus 2, minus 5, and the y-intercept at 15. Okay, so part C, solve the inequality f of x is less than or equal to 40. So I saved the other two answers that we had to A and B in case we need them. And now we need to solve this inequality. So the easiest is going to be if we use the form that we found in part A. So instead of f of x, we're going to write down this function. And now we can just unpack this. So we're going to add 5 to both sides. And then we can divide by 5 on both sides. And now we take the square root. But when we do that, we have to think that the square root of the left-hand side is going to be x plus 2. But that can actually be between negative 3 and positive 3 for this squared to be less than or equal to 9. And now we can subtract 2 from all 3 sides. So we get that x is between negative 5 and 1. And we should probably look back at the graph to check that that makes sense. So we needed the function to be less than or equal to 40, which makes sense that it's going to be between these values here. So at negative 5, it's going to equal 40, and at positive 1, it's going to equal 40. Okay, so part D, the function g is defined by g of x equals ln x, where x is a real number greater than 0. And we have to write down an expression for FOG of x. So this is a composite function. It means the function f of the function g of x. And g of x was ln x. So we're going to substitute ln x instead of x in the function. And let's use this form. So we have 5 times ln x plus 2 squared minus 5. And part 2, solve the inequality FOG of x is less than or equal to 40. So we now have this expression less than or equal to 40. And we can take a shortcut here, because for part C we solved the same thing but for x, and we found that x was between -5 and 1, and now instead of x we're going to put ln x. So it means that ln x is going to be between -5 and 1, and if we do e to the power of each of these, we get e to the power of -5 is less than or equal to x, which is less than or equal to e to the power of 1, which is just e. So that's the solution. Alright, question 9 has a very complicated setup with a cylinder inside a sphere. So I'm going to assume that you've read the question already, and we'll get straight into solving it. So let's do part A. By considering triangle ABC, show that capital R equals little r times cosine of theta. So let's draw a sketch of the triangle ABC, and theta is here. And we know that AC is H. We know that BC is going to be 2 capital R, because it's the diameter of the cylinder. And we also know that the hypotenuse is going to be 2 little r, because r is the radius of the sphere, and this is the diameter of the sphere. So this is the triangle we have, and we're going to show that r, capital R, is equal to r cosine theta. So let's do cos theta, and it's the adjacent over the hypotenuse, so 2 capital R over 2 little r. And this is already looking very similar to what we need, so we rearrange to get that capital R equals r cos theta. Okay, and part 2, find an expression for h in terms of r and theta. So looking at the same triangle, we can do sine, so that we get h. So sine theta is the opposite over the hypotenuse. And that means that h is equal to 2r sine theta. Part B, hence or otherwise, show that the total surface area s centimeter squared of the cylinder is given by this expression. So we're going to need this formula that we already have, and also this one. And the curved surface of a cylinder is in your formula booklet, and that's 2 pi r. We have to use capital R, and then times h. So this is the surface area of the curved surface of the sphere, but we also have 2 circles, and each circle has a radius of r as well. So we're going to have 2 times the area of a circle is pi r squared, and all of this is going to be the surface area. And now we're going to substitute in r and h, because we want something in terms of little r only. So capital R and h we're going to substitute in. So 2 pi times r cos theta times 2r sine theta plus 2 pi and then r cos theta squared. And if we simplify this, we can combine these two. We have 2 and 2, so we have 4 pi r squared cos theta sine theta, and we're adding on 2 pi, and here we have r squared again times cos squared theta. So we have 4 pi r squared and 2 pi r squared, which means that we can put 2 pi r squared outside the brackets, and we're left with 2 cos theta sine theta plus cos squared theta. Now we have to compare this to what they're asking for, and they have something that has minus sine squared instead of plus cosine squared, which means that we're going to use the identity sine squared theta plus cos squared theta is always equal to 1, and that means that we can substitute cos squared theta by 1 minus sine squared theta. So if we put that in here, then we get that s is equal to 2 pi r squared 1 plus 2 sine theta cos theta minus sine squared theta, which is what the question asked for. Okay, so part C, the external surface area of the sphere is 2s, and we have to show that tan theta is equal to 2. So we had our expression for the total surface area of this cylinder, and now we know that the total surface area of the sphere is double that. So we just need to know the formula for the surface area of a sphere, which is in your formula booklet. The area of a sphere is 4 pi r squared, and we now know that that's the same as 2s in this case. So if we write down the whole of 2s is going to be 4 pi r squared times all the stuff in the bracket, and we know that that's the same as 4 pi r squared. So luckily 4 pi r squared appears on both sides, so that they're going to cancel. So we're dividing by 4 pi r squared on each side, which means that we're left with a 1 on the right hand side, and we also have a 1 on the left hand side, so they also cancel and become 0. So now we're subtracting 1 from each side. We get 2 sine theta cos theta minus sine squared theta equals 0. So we can factorize this, saying that sine theta times 2 cos theta minus sine theta is equal to 0, and we know that sine theta is not equal to 0, because that would be if the angle was either 0 degrees or pi degrees or 180 degrees, which is not the case here. So we can divide through by sine theta and say that 2 cos theta minus sine theta equals 0, which means that 2 cos theta equals sine theta, and we wanted tan of theta, so we're going to divide through by cosine, because sine over cos is equal to tan. So therefore tan theta equals 2. Right, this is the last part of the whole paper. Question 9, part D. So well done if you're still here. We now know that the volume of the cylinder is V centimeters cubed, and we have to find V in this form. And the volume of a cylinder is the area of the base of the cylinder, which is pi r squared multiplied by the height. And we want something in terms of only little r. So we don't want capital R and we don't want h. So we're going to be using these two to substitute those. And that gives us pi times r cos theta squared times 2r sine theta. Okay, and we can simplify this a bit. The 2 we can put outside. We still have the pi. And how many r's do we have? We have r squared and 1r. So r cubed cos squared theta times sine theta. And this part is looking good already. We just need to do something with the cos and sine. And we already know that tan theta equals 2. So we can draw a little triangle to work out cos and sine. So tan theta is 2, which means that the opposite is 2 and the adjacent is 1. And that means that the hypotenuse is the square root of 2 squared plus 1 squared, which is square root of 5. So that means that sine theta is the opposite over hypotenuse, and cos theta is adjacent over hypotenuse. So we now have expressions for sine theta and cos theta, and we can substitute those in. So v is equal to 2 pi r cubed and 1 over root 5 squared times 2 over root 5. And let's simplify this a bit. So 1 over root 5 squared is 1 over 5. So we got 2 over 5 pi r cubed times 2 over root 5. And we want to rationalize the denominator by multiplying top and bottom by root 5 over root 5. And that means that this 2 we can multiply with that 2. So we have 4. And then in the denominator we have root 5 times root 5, which is 5. Multiplied by 5 is 25. Pi r cubed, and then we still have a square root of 5. So that's the end of the whole paper.